The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Welcome to this webinar, uh, Fabrication Design with SOLIDWORKS. My name is Abbas Madraswala, an allied application engineer and a part of Intercad technical support team. So in this webinar, we are going to discuss about fabrication design using two modules. So first is the sheet metal module and the second one is the weldment modules. So in the sheet metal part modeling, I will also explain you the gauge table, flanges, hem, and how to create a DXF output used for laser cutting, and we'll also create a drawing for the sheet metal part. After that, we'll go move on to the weldment, which is a structural modeling, and that I will show you 3D sketches, structural member, weld bead, and how to create a cut list. And then we'll also see how we can create our drawings for weldments. So I will be showing you the complete modeling of this particular work table. So in this, you can see there are two components. One is the tabletop and the second is the table frame. So the tabletop, I will model it using the sheet metal module, and the frame I will model using the weldments module. All right, so many of you are new to SOLIDWORKS, so I will be explaining you in detail how the interface works. So we'll start with creating this, selecting a new template. So I will select a part template and click OK. So this opens a blank part. So on here you can see there is a blank screen where this is the graphics area where we will see the actual model. And on the left side over here, this is the feature manager design tree where all the features we are creating will be saved over here at this location. And the top, you can see there is a command manager. So here all the tools which will require for modeling are available in this particular tabs. So we'll start first creating a sketch on the top plane. So I will select a top plane and I will start my sketch. So all the sketch related tools are now active. So I can use line tool, circle, rectangle, and so on. So I will start by creating a center rectangle. So I will start from the center point and click on the second point to end this rectangle. So I have to constrain this particular sketch. So I will be constraining this sketch by using dimensions. So if you observe, this particular sketch is right now it's underdefined. So we can see the sketch is underdefined by two methods. One is first in the status bar, which it shows that it is underdefined. And secondly, also we can identify that the sketch is underdefined with the color of this particular lines. So the blue lines over here indicates that it is underdefined. So I will start dimensioning this particular rectangle. So my table is 1500 by 750. So I will enter 750 mm, and for this particular line, I will enter 1500. So after dimensioning it, you can see that this color of the sketch is now turned to black, which indicates that this is fully defined. Also on the status bar, you can observe that the sketch is now showing me as a fully defined. So after creating a sketch, I will go to this sheet metal tab in this command manager, and I will start with my first command, which is the base flange. So with the help of this base flange, what we are going to provide is we are going to specify what is the thickness of this particular sheet. So we can specify all these things manually by entering over here. Our second method is we can also use a gauge table. So if you select this gauge table, you will see all the list of tables which you have saved. So these are nothing but the Excel files. So these are located at this particular location. So I will just open this particular window for you. Uh, So these are all the sample files which are default stored at this location. And for this particular case, I'm going to use this K factor sample. So I will just open this particular file to see what exactly this contains. All right. So this Excel table defines the different thicknesses, and it defines the K factor for different radius for this each thickness. So over here, for this thickness, so this thickness is 1 mm, and these are the K factor values for different angles and for different radius. So for each thickness, we can specify different radius, and we can specify different K factor for each particular radius. So if you have some different radius, you can just modify these values, or you can just change it over here. So in this table, there are only two thickness which are defined, which is 1 mm and 2 mm, but you can still add on in this particular table by just copying paste and just modifying the values. So whatever you are adding it over here, it will be displayed in this particular table over here. So let me select the K factor table. So once selected, what will happen is it will show me the properties for that particular table values. So over here we had two gauges, which is gauge 5 and gauge 4. So gauge 5 is the 1 mm thickness, and for gauge 4 is a 2 mm thickness. So for this example, I'm going to use the gauge 4, which is 2 mm thickness. And it has all the three radius which we have defined, so 1, 2, and 3. So depending on what is your bend radius, depending on the tool which you have, you can select that radius. So for this case, I'm going to select 2 mm as a bending radius. The next thing is also the bend allowance. So this is a K factor type of bend allowance. So we have already defined in that particular table, so it's using the gauge table. So once selecting all these particular values, I will click OK to define this particular sheet. So this is still just calculating it, and it's applying. So based on this gauge table, it has applied a thickness of 2 mm for this particular rectangle. So after that, I will add some flanges to this particular sheet. So first is I will show you the edge flange. So I will select the edge flange tool, and I will select the edge for creating this edge flange, and depending on my mouse cursor where I drag it, the direction will be applied. So I want to apply it in the downwards direction. So I will just click over here. I can select multiple edges as well. So I will select all the 4 edges. So it is in this property manager, you can see that in the flange parameters, the 4 edges are selected. It will use the default radius, which we use in the gauge table. So if we are selecting multiple entities, so there is also a gap option. So this gap option is the clearance between the two at this flanges at the corners. Then next is we can also change the bend angle. So if you require something bend angle other than 90 degree, you can just enter it over here. The next important is the flange length, how much the flange length I require. So for this particular case, I require a 50 mm flange length. I can also specify what should be my flange position. So just let me just orient this to the side view. So this indicates where your flange position is. Right now it's selected as material inside. So the edge of my plate and the bend face is on the same plane. If I select from material outside, then the inside face of this particular flange is coinciding with my edge of this particular base flange. If I select this bend outside, so the bend will be started from the outside. So depending on what dimensions you are providing to your base flange, and you have multiple options to select it. So for this case, I'll select material inside, and I will click OK to apply this flanges. All right. So I want to apply 2 more edge flanges from this particular edge. But before showing that, I want to show you one more feature. So let's say I just want to create one edge flange over here, and I want now this will be a sharp edge over here. So to make a round edges over here, what I can do is I can select the hem tool. I can apply a hem tool. So again, for applying a hem, we have to select the edges. So it will show me a preview. You can select what type of hem you require. So this one, so there are different types. So first one is a closed one. Then the next is open. So then the next one is teardrop, and the last one is a rolled. So depending on the option which you select, you have different properties to be entered for defining that hem. So if I am selecting a closed hem, so I need to just specify the length of that particular hem. Even over here, I can specify whether it should be material inside or it should be starting from the outer edge. If you want to reverse the direction, I can select reverse direction to apply it. We'll just click OK to show you how the hem looks. All right, so for this case, we don't require a hem, so I will just undo the step again. And what I will do is I will again edge flange on the bottom edges. So I will again select the edge, drag in the direction where I required, select other edges. So if you are selecting multiple edges, it is automatically trimming at the sides. Again, I will just specify the length of this one. So I require 20 mm for this one, and then click OK to apply it. And the last bend is again in this, starting from this edge in the upwards direction. So I will again click on this edge flange tool, select the edge, and I require, even if I drop it in downwards direction, I can still change the direction from the property manager. So I just need to use the reverse direction for changing the direction of this flange. Again, I will select multiple edges over here. All right, so again, I'll specify the length of this one. So I will specify 12 mm as a flange length for this one. If you observe over here at the corners, it's automatically applying a custom relief. So this one is by default was selected a rectangular relief, but if you want to change it, you can even change the relief type. So if I select this custom relief type, so right now it's selected as a rectangular. So you can either apply a oblong or even a tier one. So I'm going to use a default one. So it's selected as a relief ratio. So ratio is 0.5. So 0.5 relief ratio means it will, the gap between these two is the 0.5 times the material thickness. So right now it's a 2 mm thickness, my sheet. So it will apply a 1 mm gap between this cut. So I'm going to use this particular relief. All right, so this part is almost completed. I can also apply material to this one. So I can apply the material using this edit material option. I will apply the sheet as 304. All right, so I will save this part first. I'm naming it as tabletop. All right. So once this part is created, you can see the flat pattern view of this particular component. So in the sheet metal tab, again, I have this flatten tool. So if I click on this, it will show me the flat pattern of this particular part. Just wanted to show you a few more things over here. So if you see your feature manager design tree, there is a flat pattern folder which is created. If you expand it, so you will see this flat pattern 1 feature. I will edit this particular feature. So in this flat pattern, what it's doing is it's also applying a corner treatment over here. To see the difference, what happens is I will just uncheck this option. So you can see that there was a automatically corner option treatment which was applied, and this cut was simplified with the material adding over here. But still you can apply a manual way of corner treatment. So there is a corner treatment option over here. So you click on this corner trim tool. You have an option to collect all corners. You can then select what type of relief you require. So if you expand, you have a circular, square, or a bend base. So for each relief type, whatever you select, you can select the values which you want to apply. So I'm just going to use the default one, which is from the flat pattern. So I will again select this corner treatment and click OK. All right. So once I've completed, so now there are two things which I require. One will be the drawing for this particular one, and another will be the DXF file required for the laser cutting purpose. So to get the DXF output, what I can do is I can just right click on this flat pattern one feature, and I will get an option of export to DXF. So I can give a name for this particular DXF file. So after I click on the save option, I will get this property manager. So it asks me what you want to export. So I want to export this sheet metal body, and what are the entities I want to export. So I only require a geometry, but if you want to see the bend lines or even some features which you have applied, you can select this particular options. So for this one, I will just use the geometry option and then click OK for this one. So what it will do is it will show me a preview for the DXF. So if there are any extra entities or any extra lines, you can select that lines, you can remove that entities as well. And if everything is okay, you can click on this save icon, and then it will save that particular file. So that file which is created, you can give to your laser cutting or to a nesting program. All right, so next is we'll create a drawing for this one. So again, I will use this option, which is make drawing from part or assembly. I have to select a template. So drawing ISO template I will select. The size of this paper I will select as A3 size. So when I create a new drawing for the sheet metal part, what it will do is it will automatically generate the views in this particular view palette. So it has generated for me the flat pattern view as well. So I can insert this flat pattern view directly by dragging and dropping on my drawing sheet. So in this particular one, it will show me the information for this particular flat pattern, like how the bends are there. So it's bending in this particular downwards direction. The angle for this bend is 90°, and the bend radius for this one is 2. So for all the bends, it will list all this bend nodes over here. So you can, if you select this particular view in the property manager, if it's not displayed, just make sure that this bend nodes option is selected, and this will be appear on your view. All right, so next is I will insert some views as well. So I will insert a top view on my drawing. What I will do is I will insert some section views as well. So before doing that, what I will do is there are some tangent edges visible over here. So what I will do is I will remove that tangent edges. So I will just right click on this particular view, and I will click on this tangent edge, and tangent edge is removed. If you want to even dimension this particular view automatically, so we can do that. Just select this particular face, and I will use the automatic in the annotation, which is the model items. So this will generate dimensions for this particular view. So I will then now create a section view. So from this view layout tab, I will select the section view tool. I will place where I want to create my section and then click OK to confirm it. And it will generate a section view for me. All right. So I still want to show a detailed view of this particular bends over here. So what I will do is I will use another tool, which is a detail view tool. So I'll select that and I will just create a circle over here and then place it on my drawing sheet. I can change the scale of this particular view, or the 1:1. So if I want to dimension this, I can even give a reference dimension. So this is a manual way of defining it. So I can select a smart dimension tool and I can just select the edges to place the dimension. I can use this rapid dimension for placing these dimensions. All right. The last view I just want to show it on the drawing is the isometric view. So I can again drag it from this palette. You can also change the display style of this particular view. So if I want to show it in the shaded view, I can select shaded with edges. And just the last thing about this one is this information, which is the bend notes, you can also create in the form of a table. So if I right click on this particular table view, I can click on this table and I have an option for creating a bend table. So if I click on this bend table, select the template and just place that table in my drawing sheet. So now this is replaced with the tagging, which is ABCD, which is individual for each particular bend, and it's showing the information for that particular bend. So the bend A is in the downwards direction, which is 90-degree angle, and the inner radius is 2 mm. So these are the information which is required for the bending purpose. All right, so we have completed the documentation of the sheet metal part. The next is we'll move on to the weldment parts to create the frame of this particular table. So again, I will select a new template. I will select the part template, and this will open a new file. So last time we used a 2D sketch. So this time I'm going to show you a 3D sketch. So 3D sketch is again in this particular sketch tab. So click on this icon and select the 3D sketch option. So now if I select a tool, so let's say I'm starting again with the rectangle tool. So if you observe my mouse cursor, you can see that there is a XY which is showing. So right now it's showing that if I start creating a sketch, it will create in the XY plane. So I will just click on this particular point. So it's creating in my XY plane. But if I want to change the plane direction, so I can just hit the tab key on my keyboard, and then this will change the orientation for this particular one. So right now it's in the XZ plane, which I require it. All right. So again, I will define this particular sketch with the help of a smart dimension tool. All right. So now the length of this particular sketch is I will enter in the form of an equation. So this sketch which I'm creating is a skeleton sketch for that particular frame. So the tube which I'm going to use for this particular frame is 40 by 40 square tube. So what I will do is I will use my length, which is the 1500, which is the length of the table, minus the 20 mm bends, the two bends which are of 20 mm, and again I will subtract the 20 mm the square tube sections. I also require a clearance of 1 mm on each side so that it's easily fabricated. So I will enter -2 as a clearance, and I can just click OK and it will automatically calculate that value for me. I repeat the same thing for this one. So again, 750 minus the 20 mm, the two flanges, and again the square section and the clearance, which is 2 mm. All right. So even after defining this 2 dimension, the sketch is still not yet defined because this is a 3D sketch. So I have to tell this particular sketch that this line is in the X direction. So this is along X. So if I select this particular line, I can say that this line should be in the along X. Similarly, for this particular line, I wanted that it should be in the Z direction. So again, I will select this along Z. So this will define my sketch over here. Now I will sketch a few more lines which will represent the leg of this particular frame. So again, I require it in the Z direction. So again, I will use the tab key for changing the orientation of my sketch. All right. So these are the four lines for the four legs. So I will give them equal relations. I will select all these four lines and tell the software that it should be equal. So I will provide the dimension for this one. The table height I require is 900. So I will enter right now 900. And I will also apply some stiffness section over here. So I will again create two more lines over here. And one more line I will create it in this particular site. All right. So again, I will define this two lines. So again, these two lines I want of equal length. So I will select these two lines and give them an equal relation. And I will give them a dimension over here by adding a dimension. So I will select this point and this particular edge, and I will give them a dimension of 300 mm. Similarly with this point. So I'm not going to create these two lines on other three sides, because what I will do is I will use the mirror tool for mirroring these bodies. So this completes my sketch. So I will exit my sketch. So this represents a skeletal frame sketch for my model. So after creating this frame sketch, what I will do is I will assign the structural members to this particular sketch. So for that, I will use the weldments module. So I will select the weldment tab and I will click on the structural member tool. So just a little bit of this profile. So these are the standard profiles which are already defined. You can download this profile as well. So I will just show you the location where it is. So if you go to this design library section, there is a SOLIDWORKS content. And if you click on this weldments folder, you will see the different type of standards which are available. So you just need to click on this and it will download this particular standard. So I have downloaded this AS standard. And once you have downloaded, you have to just put in the right location. So you can check where your location of this particular file is. So if I will just show you that particular location. If you go to the option, this options, and in the file locations, you can specify this weldments profiles. So I would always recommend to not use the default installation locations where SOLIDWORKS is keeping, or try to create your own folder location and then add this location over here. So what happens is when next time if you upgrade your software, so your custom profiles will not be lost. So once added over here, if you select the structural member tool, it will be showing over here. So I'm selecting the AS standard. I'm selecting the type of section as a square hollow section, and the size is 40 by 40 section. So for applying a structural member, I just need to select these lines and it will assign this members to this particular line. If I select multiple lines, it will assign the profiles. So what it's doing, it's automatically trimming the edge over here. So you can change this corner treatment. So you have an option that you require a miter cut or a end but one or a end but two corner treatment. You can also individually change by just clicking on this pink dot. So if I click over here, you can change the style of this particular, for only this particular corner. I will repeat the same for over here. All right. So these are the 4 lines which I've selected. Now, if I try to select this particular line, it will not allow me because it is not in the same plane over here. So what I will do is I will, in the same property manager, I will click on this new group icon and I will now select the 4 members, which are the legs. Again, for selecting this particular member, I have to create a new group. You can also align your profile. So right now it's required a rotation of 45 degrees. So you can change this angle from here. So I will specify the angle as 45 degree and it will align over here. One more thing, if you observe that it is automatically trimming as per the body sections. So my line is starting from here, but it's trimming. It knows that this is an intersection and it will trim at this particular locations. Similarly, I will again create one more group to add this particular line. So this is aligned properly and I will click OK to complete this step. Okay, I will just hide the sketch. All right, so now I will show you a few more tools over here. So in the Weldments tab, there is one gusset tool. So for gusset tool, you can just select the faces where you want to apply it. So after selecting the 2 faces, it will insert this particular gusset at this location. So there are 2 profiles which you can apply. So one is a triangular profile and another one is a polygonal profile. So let me select this polygonal profile. So whatever profile you are selecting, that dimensions you have to specify in this particular boxes. So for this one, I require a 100 mm length D1 and 100 mm length for D2. I will click OK to accept it. Another thing is you can also change where you want to apply this particular plate. So you can change the thickness, which is the inner side or the outer side, or the plane is in the middle. Or you can also specify the location for this one. So based on the face which you select, it will select apply at this particular locations. So I will click OK to apply this. The next thing is you can also apply the end cap at this particular location. So if I want to apply an end cap, I will click on this end cap tool and select the face where I want to apply it. I can specify the thickness for this particular plate. So let's say I require a 3 mm thickness plate. You can specify whether you require as an outward or inward or internal. So if I click on this internal, so this plate is applied internal to this particular section. But what I require over here is the this internal one, because what it will do is it will trim this particular body as well. So I will select the other 3 faces as well. And then click OK to apply it. All right. One more thing I want to create is a base for this particular frame. So I will start a new sketch at this particular face. And I will sketch a rectangle. So this time I will use a corner type rectangle. I'm giving the dimension with reference to this edges. So I will use a smart dimension tool. Similarly for this particular edge. And the last edge will be over here. I'll specify the length of this plate as 100 mm. Alright. So once my sketch is complete, I will again go to the weldment tabs and I will add a material by using this extrude boss tool. So you can select the direction which you require. I will just reverse the direction so that I can show you one more tool, which is a trim tool. So right now this one is intersecting with the tube over here. Just make sure that the merge result option is not selected, so it will create it as a separate bodies. Okay, so before using the trim tool, what I will do is I will mirror all these bodies on the other three sides. So what I will do is I will select a center plane and I will use the mirror option. In the mirror option, I will select bodies to mirror and I will select the bodies which I want to mirror. Similarly, I will repeat the same on the other side. So I will select the center plane again, use the mirror tool and select the bodies. All right, so now there is only one interference on the base, so we can easily remove it with the help of a trim tool. So in the weldments tab, again I will select the trim or extend tool. So in the first box, I will select bodies to be trimmed. So I will select the 4 bodies which I want to trim. Now, since this is a solid plane, I have to use a face or a plane, but if you are trimming between 2 structural members, you can use the bodies option as well. So over here, I'm going to use a face plane. So I want to trim at this particular location. So what it will do is it will automatically identify that which needs to be discarded. So on the bottom side, it's discarding the material. And on the top side, it's keeping this particular bodies. In case if you want to keep the bodies, you can just click on this and it will change it to keep. But I don't require it, so I will discard, just make sure that these 4 bodies are discarded and then click OK to apply it. All right, so next for fabrication, we require the welding information. So there is a weld bead tool as well. So I will select the weld bead tool. So there are different ways which we can use this particular tool. So first is I will show you with the weld geometry. So over here we need to select the 2 faces. So one face and the 2 face over here. So this will apply the welding at the intersection location. I can specify what radius I require. So let's say I require a 3 mm radius. I can select the selection. So I require it all around. So it will apply all the edges over here. Once this is applied, I can click on new weld path and I can select the other 3 as well. I'm only going to show you on this particular site, so I'll just show you a different ways. There is also a smart weld selection tool. So it's a very easy way of applying the weld path. So if I just select this, drag the line over here, it will automatically select the edge and it will apply. So instead of selecting the face, I will just select this smart weld selection tool and drag it from one face to the other face. Similarly, I will apply it at this location. Now at this location, I don't require an all-round weld. I just require on the both sides. There is also option if you want to show an intermittent weld. So if you click on that, you have an option to specify what should be the weld length or a gap. So let's say I have a weld length of 10 mm and the gap also 10 mm. Oops, sorry. I will again apply that. Both sides, and I will select the intermittent weld and insert 10 mm to apply that. So this will create automatically the weld symbol, and this can be imported in our drawings. All right. So I will save this particular part as well. All right. So another thing, if you observe that in the feature tree, it is creating a cut list over here. So if you expand, if I expand this, it is segregating all the structural members based on the length and the section which we are using. So these two are of the same length, and it is a 40 by 40 section. So it's segregating in terms of this particular folders. These are the four gusset plates, and these are the four end caps and the four plates. So it automatically segregates it, and this we can import it as a cut list table in our drawings. So let's create a drawing for this frame. So I will use this again, make drawing from part, select the template, so again it will populate all the views in this view palette. So I just need to drag it and place on my drawing sheet. So I will insert the front view, the top view, the side view, and also I will insert the isometric view. Just reposition it again. I will show this isometric and a shaded view. Now I want to import the cut list table, which we just saw. So I will right click on this view and I will go to tables and select the Weldman cut list table. So based on what we have created, so it lists all the sections and also the length for that particular sections. Now these are the three plates which we have inserted. So there is no description, but still we can create a description automatically based on the length what we have defined. So I will go back to my model. So this one, this four items are my gusset plates. So if I right click on this particular folder, I can access the properties for this gusset plates. So now you can see there are only two properties which are over here, which is the material and the quantity. Again, if I right click on this particular folder, I have an option to create a bounding box. So if I click on this create bounding box, it will, you can see that it is renamed this particular folder. So now it's showing me the length of this particular plate based on this bounding box. So if I again access the properties for this one, you can see that there are few properties which are added over here. So the thickness, width, length, and the volume. And the description is also automatically added over here based on this particular dimensions. So this value will be now inserted into my cut list table. So I will repeat the same for the end caps. So I will create a bounding box and for the base plates. So if I go back to my drawings, so this will update my cut list table. All right, so next thing is there is an item number for this one. So I will use the auto balloon option for ballooning this frame. So you can use different type of layouts. You can use different settings over here. I am going to accept the default ones. All right. So the next thing what we require is again uh, the dimensions for each particular body. So for example, for this particular body, I just want to show this particular body in my drawing sheet. So what I will use, I'm going to use this relative view tool. So I will select this particular tool and select the isometric view. So what it will do is it will open the model, and then I can select the bodies over here. So I will use the selected bodies. I just want to create a drawing for this particular body, so I will select this body, and in the orientation I need to define two orientations. So in the first orientation I am going to select the front plane, and for that particular face I will select this face. So this face will be acting as a front face. In the second orientation I'm going to use the top orientation, and in the face I will select this face as a top orientation. Once selected, I will again click on this OK. So this will switch back to my drawings, and then I just need to place the view on my screen. I will again I will just modify the scale for this one. I can project the view as well. And now I can just dimension this particular drawing, this body. I'll just repeat the same for the gusset plate. So I will again use the relative view tool, click on this bodies. Again, use the selected bodies. Now this time I'm going to select this gusset plate. For the front face, I will select this face. And again, in the second orientation, I will use the top orientation. And in that, I will select this particular face. So by default, I just need to place this on my drawing sheet. I can change the scale as well. So this way I can create drawings for each bodies which I require for fabrication purpose. All right, so we have completed the drawing for this structure as well. So the last thing remaining is assembling this frame and the tabletop. So I will again create a new assembly file. So I will select the assembly template. So from this one, I will select my first component which I want to insert. So I will insert the table frame. I will click on this green check button. So this will insert my first component. So the first table which is component which is inserted will act as a fix component. So fix means all the degrees of freedom for this particular component is constrained. Second component is my tabletop. So I will select this table and I will just place it in my graphic screen. So right now it is not constrained. I can move this particular table. So I have to assemble this top on this particular frame. So I will assemble by using the mates tool. So I will select the mate tool and I will select the faces which I want to assemble. So I want that this face is coinciding with the inner face of this particular top and apply it. Now I want to orient this in the center of this one. So what I will do is I will select the center plane of both these components. So I will use the right plane for the table frame, and I will also select the right plane of my top. Similarly, I will select the front plane of my tabletop and the front plane of my frame. So this completes my modeling of my tabletop.